bag. So first thing about your present. Next, I will talk about some setups that you can make with it, and the last part will be the some configuration examples of Capsman. So, if you already opened your box, you should see a device something like this. It's called wAP. It's the wireless access point. We have in two colors, black and white. And today you should receive the white one. So it has the quite fast CPU for the home access point, 650 megahertz. It has 64 megabytes of RAM and 16 megabytes of SPI flash. So it also has the one wireless interface, 2 gigahertz dual chain, 100 megabit Ethernet port. You can power it from passive PoE or AFAT or the power jack. Its operation temperature is from -40 to +70, and it's waterproof. It has the waterproof casing, so you can't put it in the pool or something like that. But you can make it under the roof where some rain splashes or not a lot of water. So the first example how you can attach it to the wall, we have included all the brackets, all the templates. So you just put on the wall the template, drill the holes from it, and screw in the brackets. Also, the Ethernet cable can be put through the hole so that no wires are hanging off the walls. Another option, you can attach it to the ceiling. Very similar process. Just use the template, drill the holes and attach it, and hide the cables in the ceiling. So by default, it comes with configuration, very useful for home users. First Ethernet port is considered the WAN port. It's protected by firewall. It has masquerading, DHCP client, and neighbor discovery is disabled. So many customers are writing to us why I can't connect to the router when they attach the Ethernet cable. This is the main reason, because it's protected and discovery is disabled. You can't even see it. And the wireless interface is configured as access point. It has DHCP server and default IP address from this range. So to connect to this router, you can't use the Ethernet because it has only one Ethernet, which is the WAN port. So you have two options. One is when you use your laptop, connect to wireless interface and use Winbox or Webfig or Telnet or SSH. It's open from local interface. The wireless is considered the local interface. The other option is to use your Android device we have developed a new application. It's called TikUp, or you can use the WebFig, which is a web-based application. So, by default, we are leaving the default username, which is admin without passwords. So if you don't need this configuration specifically, but you want to configure something manually, the easiest way, I think, is to switch default configuration to cap config, which can later be used either as a cap client, or you can just easily connect to Ethernet port and wipe out all the configuration. By default, it's wireless and Ethernet interface bridged and DHCP client enabled. So to switch to this configuration, when you power on the router, hold the reset button for approximately 10 seconds. So here's the example of TikUp that I mentioned previously. So you can see this login screen on the left side and the reset configuration screen on the right side, just for information. So if you want to use it, you can go to our forum and apply to testing program, because it's still in alpha version. And when you apply to this program, you can download it using the Play Store. And currently it's only the Android device, on Android devices. So if you choose to leave the default configuration for home users, you need only 3 things to make it more secure. After connecting to the router, change the username and password, disable admin user, and set wireless key to protect your access point. And basically that's it. So if you already have the router at home, but you have a large home and one device is not enough to cover all the house, then you can use it as a repeater. So let's say the router that you already have has a good coverage, but the mobile devices or any customer device does not have such good range. So you still need to extend the wireless coverage with other routers, like a repeater. To make a repeater, you need either router with 2 wireless interfaces, or you can use the virtual access point. I will talk about a little bit later, but let's say, for example, this is considered to be a large house. So we have 1 access point, and on the left side, the devices can reach the router, everything is fine. But on the right side, the coverage, for example, of the laptop is not so good, and it cannot connect to our access point. So we simply add the repeater on the second side of the house, and that should provide the connection for other devices further away from the main router. So to make the repeater configuration, first things to do is make a station for the physical interface. There are 2 things how to do it. First is if you do it manually, make the configuration of SSID, band, and station mode. If you have authentication, secured your access point, then you have to manually configure authentication data also. To connect the repeater to MikroTik access point, you should choose the station mode should be station bridge, because then you can bridge the wireless interface and use it transparently. The second method is to use the wireless scan tool. So it's the Winbox screenshot. It's in a wireless menu. Press the scanner button, then scan window opens. Press, and here you can see the 3 access points discovered. So you just pick one from the list and press connect button. The same from TikUp. You just choose the wireless interface, press the scan, and all the access points discovered you can see on the screen on the right side. So one feature you can see here is the background scan enabled. This means that when you scan your wireless interface, it will not disconnect you. In this case, if you have a wAP device from which you connected by wireless interface, whenever you press the scan, it will disconnect without the background scan. But if you click the background scan, it will run on the background and you should stay connected to the device. There are some limitations. It works only on 810.11 protocols. Wireless interface should be enabled, otherwise it will not work. It works for both access points and stations. And also you can run it on virtual access points. Whenever you want to use it in scripts or some other tool, you can also export in CVS format file. So the next step for our repeater setup is to make the virtual access point interface, which you add on the physical interface that we configured like a station. We are using the same SSID and security profile. Then we add the bridge interface and bridge the wireless and wireless access point and wireless station, so that we can provide the transparent services. So for management, you can add the DHCP client to the bridge interface, so if you need the IP connection. So to measure throughput, you can use the integrated bandwidth tool. It's not the most precise tool, but you can use it just for make sure that traffic is going through the interfaces. So if you don't want to fill out security information manually, you can use the VPS client, which RouterS is now supporting. It will allow to get you the pre-shared keys and get the information and show it on the screen, so you can either copy it automatically to security profiles. So the next part is about Capsman. Capsman is our controlled access point system manager. It allows to manage all the access points in your network through one device. So if you change the, for example, configuration, single setting in one access point, you can do it by just adjusting that setting in one manager, not to go through every access point that you have in your network. So some abbreviations. The first, Capsman, like I said, it's Control Access Point System Manager. Next is the CAP. It means it's a controlled access point. Devices that are connected to a manager and managed by, and which interfaces are managed by the manager. So CAP itself doesn't need much configuration. It simply needs to lock wireless interfaces to the Capsman and need some connectivity to Capsman. Either it is IP connectivity or layer 2 connectivity. So when the Capsman received a configuration, packet forwarding from the clients can be done in two ways. One is the central, which is done by default, and second one is the local forwarding. The difference is, let's see the example of local forwarding. Let's say we have a configuration, full mesh configuration of 4 routers. One is the gateway, which has the connection to internet. Then we have a manager and 2 CAP devices. So the yellow lines represent the flow of configuration. Manager sends the configuration to CAPs, and clients later connected to CAP sends the data. Let's say we look at the lowest one. The green lines represent data flow from clients connected to CAP going to the internet. So you can see that traffic flows right to the gateway and to the internet. The second method is when the some pros and cons about this method. The first one is that manager can be a very weak router. You can use it like your own device that you received today. Just a regular home router can be the Capsman. Link between CAP and manager is also not so important, just to give connectivity to the internet if it needs. That's it. And when the CAPS manager goes down for some reason, some failure, hardware failure or something like that, then clients connected to CAP do not lose a connection to internet. So some cons. It's not so friendly for central management. You still need to make the firewalls if you need a hotspot or DHCP servers or something like that. You have to use it on the CAPs. Each CAP should have its own firewall or its own hotspot and so on. So that's why we have also the second method. In this case, manager is doing all the stuff. So manager sends configuration, clients connected to CAP sends data to CAP, and CAP device sends the same data to manager, and manager is forwarding those packets to the gateway. So in this case, you can make the hotspot servers, queues, centralized firewalls, all on the one device. It can also be used for, easily for management. You can write your own management applications, use SNMP to monitor this router, use API to make your own applications. But it also has some cons. For example, it's the single point of failure. If Capsman goes down, then you lose then clients lose connectivity to the internet. So it's the best practice to make at least 2 Capsmans, one for backup and one like a main. Also, the hardware must be quite powerful router, because all the packet processing is done on that router. If you have extended like firewalls, extensive queues and hotspot and everything like that, it also needs the quite powerful CPU. And the last con is a link between, you can see the link between manager and gateway, which is used for all traffic forwarding, should also be very reliable and very fast. So let's, the next part is how to lock the wireless interfaces on CAP devices to be used by the manager. The configuration is very simple. You go to wireless menu, press the CAP button, and simply you need 2 settings. Checkbox and on enabled, and specify interfaces that you want to be controlled by the manager. In this case, if you use the wAP device, we just use the VLAN 1, so we have only one interface. So next, there are some other options. I will talk about only the discovery interface and the Capsman address. So discovery interface means if you have a layer 2 network, you can reach the manager by the MAC address, just a regular layer 2 network. So you specify interface on which discovery packets will be sent. If you have only layer 3 connection to the manager, then we specify a Capsman address, which is the IP address configured on the Capsman. So in this example, you also see that I have discovery interface set to loopback, which basically means that wireless interfaces that I want to control by Capsman is also located on the same device. So you don't need the separate dedicated device to use as a controller. So this is the same, only from console. Go to interface wireless CAP menu, set enabled, and specify interfaces. Yes, and also the bridge. Currently we have none, but if you have a specific configuration where you are using local forwarding, for example, in layer 2 networks, then the wireless interface can automatically be added to the bridge interface. So that was it about the CAP configuration, which I mentioned is very simple. Now we start to make the Capsman configuration. So as I mentioned, it can be on the same router. Either you use the loopback address or you use the loopback interface as I shown previously. So when for CAPS Manager to work, it needs several things. It needs connection from CAP to CAPSman. It needs the configuration parameters, and it needs the provisioning criteria. So let's start to talk the first about configuration. So we open the CAPSman menu. In the second tab, configuration tab, we press plus and make a new configuration template. So we just specify the mode access point, specify SSID that we want to use. Next part, we go to channels tab, specify the channel. In this case, we are using 2 gigahertz. And the last thing that we need to use is provide the data path. Here you can set up either it will be used as local forwarding or centralized forwarding. In this case, I'm checking that I'm using the local forwarding. And that's it, press OK. The last thing, fill in the security information that you want to use and press OK, and configuration is done. So the next part is provisioning information. So this is basically how CAPMan decides what configuration to give to devices. So there are several criteria that you can use. In this case, I'm using just the hardware supported modes to distinguish between wireless interfaces that I want to configure. So I just checked G, N, and B modes, specified action to add interfaces dynamically. I will show it later how it looks. And I specify the master configuration, which is the template that I created previously. So we also have the slave configuration. This means that if you want to make the virtual access point on the CAP device, you provide the slave configuration, and it will automatically make provision not just the configuration for the physical interface, but also will make the virtual access point. It's useful if, for example, you want to provide internet wireless services for guests, for example, and on the same router you want to provide services for some employees. So you need 2 access points. One is the open access point for the guests, and the second one is secured for local use. So in the last part, when this provisioning and configuration is done, we just need to enable the manager. So we press the manager button, manager window opens, and we just click enable. As you can see, there are several other options. It can be used to generate certificates automatically. In this case, I selected certificate to auto mode and require peer certificate. So router will automatically generate CA, server, and client certificates, will automatically send to all the CAP devices, and connection between manager and CAP is secured. But it's not the requirement. You can simply enable the manager and that's it. So when it's enabled, we can see all devices, all the CAP devices in remote CAP tab. So in this case, there's only one router. You can see its MAC address, its version, its identity, its serial number, so basic stuff that you need to know. So, and also when, as we provided here action create dynamic enabled, this means that in this screenshot you can see that one interface is already added. It's added dynamically, and configuration is already provisioned. You can also see the discovered interfaces you can see next to remote CAP tab we have radio tab. This tab shows all the discovered interfaces on all the CAPs, even if they do not appear in the first tab. So, and the last part is registration table. Here you can see all the connected clients, its signal strengths, rates, and basic registration table that you have on the regular wireless interface. So the Capsman can also be used to provision several different configurations. Let's say we have like we have here, the hub devices with two interfaces, 2 GHz and 5 GHz. So we just create two different configurations and two different provisioning criteria. First one is for B and G, and the second one is for AC. So, and CAPS Manager automatically chooses the right configuration. It also has the templates that you can use. For example, here we used a security profile for each configuration individually. But we can go to security tab on the main screen, create security template, and specify this template in configuration in the first drop-down box. This will allow to use the same security credentials for all the configurations. The same can be applied to channels, rates, and data path. So, in some of the limitations about Capsman, the first one is you can have only 32 radios per one cap. It's quite the big number, so basically I don't think it's a big limitation. The second one is that also the 32 virtual interfaces can be made on the one master interface. But instead you can have unlimited caps. Also, we had the two versions of Capsman, version 1 and version 2. Now the development is done only on version 2, and both of them are not compatible. So if you have older devices that you want to connect, then all of them need to be upgraded. And currently there is no N-Stream and NV2 support. So basically that's it. I can show you the So right now, in this conference room, we have two hub devices. One is used as the controller, and controller controls the same interfaces. So this is the controller router. We can see 4 interfaces, each for 2 for each device. As you can see in the wireless tab, it shows that all the wireless interfaces are managed by Capsman. So you can see basic stuff like what channel it uses, what SSID, and what forwarding mode. Like you see here, it's just enabled, and on the CAP configuration, we enabled, specified both interfaces, and specified discovery interface local, which basically is the same router. In configuration also, we have 2 configurations, one for 2 gigahertz. You can see the band 2 gigahertz, and the second one is for 5 gigahertz. And provisioning also 2 configurations. The first one I specified to distinguish between devices that interfaces that has GN support will use the configuration named 2 gigahertz, and the second one, the device that supports AC, will use the configuration template named 5 gigahertz. So we can see here the interfaces, the radios that I mentioned previously, remote CAP devices. You can see here one is discovered by MAC address, and the one that you see IP address, this is the locally controlled device. And the last part, registration table, here some clients, their signal strengths, MAC addresses, and so on. So this table you can use, and all the other tables to monitor this device. As I mentioned previously, create your own management tools. In this case also, they are added dynamically to the bridge interface, and I am using the centralized forwarding, which means that in this bridge interface I can make the firewalls, create the hotspot interface, and it will all be managed by this one device. So as you can see, the on hub device, which is not the most powerful router, it manages to control 2 devices without any problems. So if maybe some questions. Then that's it. Thank you for listening.